We are talking about coordinate geometry. So before you can get into CNC, it's really important to know about coordinate systems. Now, we're going to talk a little bit about numbers and then into rectangular coordinates. So the first thing is real numbers. What is a real number? So we have real numbers. Okay, so real numbers are basically whole numbers, or numbers that are basically between 0 to 9, can be digits. So we have different ones. We have integers. Integers are whole numbers. So we have like 0, 1, 2, 3. They're whole numbers. There's negative integers, which is -1, -2, -3, and so on. And of course, with real numbers, there's fractions. So a half or an eighth. So fractions are part of real numbers. And then, of course, decimals. So the decimal for half would be 0.5. Decimal for 1/8 is 0.125. So nothing really special about what real numbers are. With numerical control, we're using numbers to control the system, which is basically what it is. Now, when we get into our drawing, everything's going to be drawn basically on the rectangular coordinate system. And let's pull up some graph paper here. There we go. Okay, so now we have some graph paper pulled up here. Now, a Cartesian coordinate system, we're going to just start up here and we're going to draw one in. I'll try to follow the lines. There we go. So you can see some different things. We've got our axes on here. Okay, this is going to be our x-axis, and that's going to be our y-axis. Now, it goes way back in history where this thing started, but we have to deal with it. So this is the x-axis, and the y-axis. Let's go ahead and label those. Y-axis. All right. Now, what's right here in the middle? That's an important part of this. Okay, and that's called the origin. Or in coordinates, that would be 0, 0. Now, I understand that a lot of this is going to be maybe review or basic, but you can speed this up or get through it. Now, along with coordinates, there's some special things like we have different quadrants. And if you look, we have 1, 2, we have 4 quadrants. Okay, because it's broken up into 4 areas. So the important thing up here is this would be, say, quadrant 1. Over here would be quadrant 2. Now, they're always displayed as a Roman numeral. Not really sure why, but maybe that's just because when it started. Then we have quadrant 3. And it always goes basically counterclockwise around. Then we have quadrant 4. Okay, so all 4 quadrants. Next thing to know is when we have x and y axes, everything on this side is positive x, or at least the way we're going to define most of it, and over here is a negative x, basically. And up here is a positive y, and down here would be like a negative y. Alright, so the coordinates in here, if we were to put coordinates in this block here, this would be in the basically positive x and positive y. Over here we'd have a negative x and a positive y. I'll put a little comma here to show the difference between those. And down here we'd have a negative x and a negative y. In this quadrant we'd have a, let's see, we're on the right side of it, so this is a positive x and a negative y. So that works pretty good. Okay, I have a quick example set up here. We have a coordinate system. Once again, until you get used to it, it might not hurt to label these, the x and y axis. And if you look at this, every one of these blocks designate a 1. So if I put a point, say there, maybe there, there, and let's go out at this point here. So we have a whole bunch of different points. I'm just going to label them 1, 2, 3, 4, 5. So what's the coordinates of position 1? We're looking at that. We can say that's 1, 2, 3. That's 3, comma, 1, 2, 3, 4. So the coordinates are 3 in the x, 4 in the y. Now how about for number 2? If you look at that, it's just like when you're walking down the street. You don't count where you're at as the first block. You go a block first, then count. So 1, 2. How about position number 3? We have 1, 2, 3, 4, 5, 6, and then up 3. But we're in the negative of the axis, so it needs to be negative 6, positive 3. I'm going to go ahead and write the 4 and 5 down here. All right, so 4 would be negative 1, 2, 3, 4. And how many in the negative y, since we're below the x-axis? 1, 2, 3. So negative 4, negative 3. And then over here is 1, 2, 3, 4, 5, 6. Now we can also look, well, these are in blocks of 5. So that's 6 minus 4. So there's a quick example.